This is section 6.2 called the Pythagorean theorem. Before we get into the Pythagorean theorem, we are going to be talking about a quick review here from the last section of 6.1. Just remember, if you have a symbol before the square root symbol, you need to carry that down throughout your work. So this one is plus or minus. The square root of 36 is 6 because 6 times 6 is 36. So plus or minus 6 is the answer to the first one. The next one has a negative before the square root, so carry that down. And the square root of 16 is 4 because 4 times 4 is 16. So negative 4 is the value of this one. And the last one has no symbol before it, which implies that we just want the positive value. The square root of 100 is 10 because 10 times 10 is 100. All right, so there's just a quick review of section 6.1. Now we're going to get into some vocabulary. So leading up to the Pythagorean theorem, this is not the Pythagorean theorem just yet, but we're looking at different parts of a triangle. So the two sides in red here are the legs of the right triangle, and they're the two sides of the triangle that form a 90-degree angle or a right angle. So the symbol again tells us that this is a 90-degree angle or a right angle. So this is a right triangle. So these are the legs, the two legs of the triangle that make up the 90-degree angle. The next one here is called the hypotenuse. It's the side opposite the 90-degree angle. So going straight across from that 90-degree angle, you're going to find the hypotenuse of a right triangle. And now here it is, just like the title says, the Pythagorean theorem. So what is the Pythagorean theorem? The Pythagorean theorem says, it's going to be easier to type this one out. It says a squared plus b squared equals c squared. That's the Pythagorean theorem formula, but the full definition is a squared plus b squared equals c squared, where a and b are legs of a right triangle, and c is the hypotenuse. So that is the Pythagorean theorem. Probably one of, if not the most famous math theorem. If you square the side lengths of a right triangle, you get out the square of the hypotenuse. This is the formula that the Scarecrow in The Wizard of Oz incorrectly says. So it's a squared plus b squared equals c squared. All right, so if we go to apply that here, we're trying to find the hypotenuse, which I labeled c, so you know that c is the hypotenuse. C is always the hypotenuse, so c is always the one across from the right angle, but I just labeled it c to help you out on the first one here. It says find the value, round to the nearest tenth if necessary. So all we have to do is look at our legs of the right triangle, so 7 and 8 are the legs, and we're going to plug those in for a and b. And it doesn't matter if you plug 8 in for a or 7 in for a, but then you have to plug the other one in for b. All right, so I'm going to write down my Pythagorean theorem, a squared plus b squared equals c squared, which again we use to find missing side lengths of right triangles, and it only works for right triangles. All right, then we're going to plug in, I'm going to use 7 for a, so 7 squared, plugged in 7 for a. I'm going to plug in 8 for b, so 8 squared, and I still have c squared. I don't know what this hypotenuse length is, so I keep it a variable c. So now follow the order of operations. Exponents first, then you add after. So you can't add these and then square them. It doesn't work that way. You have to take the exponent first, evaluate the exponent, then add. So 7 squared is 49, 8 squared is 64, and we still have equals c squared. If we go to add those together, 49 plus 64 is 113. It still equals c squared. And then to undo this square, because we're ultimately trying to solve for c, we're going to square root both sides of the equation. The square root and square will cancel each other out. C is all by itself, and then we need to take the square root of 113. So 113 is not a perfect square. When we take its square root, we get out a decimal, but the directions do say round to the nearest tenth if necessary, so this is necessary. So 10.6, approximately 10.6. So I'm going to show that it's approximately 10.6 by using the curved equal sign. Approximately 10.6. Now there are no units given to us on this one, so I'm going to say that c is approximately 10.6 units, because ultimately I am finding a side length, the distance of the side length, so I'm giving it the units. So approximately 10.6 units. All right, on this one, this is a real life picture right here. This is, you can see Sturgeon Bay High School right there, the NWTC building up here, and then the YMCA building over here. So here's Michigan Street. You could actually measure this linear distance there. You could measure this linear distance there on the street over here. And then if you want to know the linear distance between the middle of NWTC to the middle of the YMCA, it would be a little bit more difficult because there's a lot of houses in the way here, right? So we can find this linear distance by using the Pythagorean theorem. So I'm going to use the Pythagorean theorem, a squared plus b squared equals c squared. I'm going to use 0.3 as a, so a squared, plus 0.7 is b, 0.7 squared, equals, I don't know the length of this one, but it's called x. It's not called c anymore, so I'm going to plug in x for c, but it's still just a variable squared. All right, so now we're going to just calculate this following the order of operations. So 0.3 squared is 0.09. 0.7 squared is 0.49. It still equals x squared. If we take 0.49 and we add 0.09, we get 0.58. And then if we square root both sides to undo that square, we get x by itself. Take the square root of 0.58, and we get about 0.76. So I'm going to use my approximately equal to 0.76. And the directions do say round to the nearest tenth if necessary, so I should not be rounding to the nearest hundredth here. It should be about let me just extend the page here. So I'm going to say x is approximately equal to 0.8, because the next number here after the 7 is larger than 5. So 5 or larger, round up. So approximately 0.8. Now there are units on this one, that's miles. So approximately 0.8 miles. So that's the linear distance between the middle of NWTC to the middle of the YMCA, about 0.8 miles. All right, moving on. So we have 2 more to go. So on these 2 problems, they're very similar. We're trying to find the missing side length indicated with this x feet. Now, remember, these tick marks here tell us that all 4 of these sides are congruent. They all have the same measure. So this one's 3, which means this one must also be 3. Well, now we just have a triangle. This is a right triangle. We can use the Pythagorean theorem to find the missing side length. So I'm going to say a squared plus b squared equals c squared. And there's actually, this is what's called it's one of the right triangles that it's just easy to memorize. It's a 3, 4, 5 triangle. So I already know that the side length will be 5, but let's just prove it. So I'm going to plug in 3 for A, 4 for B, and x for C. 3 squared is 9, 4 squared is 16. Add those 2 together, you get 25. And then square root both sides to undo the square. And sure enough, the square root of 25 is 5. And this is feet in feet, so x is 5 feet. Ooh, 5 feet. There we go. So yep, 3, 4, 5. So if you ever encounter a triangle that has 2 side lengths, 3 and 4, right away, just remember hypotenuse is 5. 3, 4, 5 triangle. All right, and this one says round to the nearest tenth if necessary. It wasn't necessary because we got out a whole number. All right, this one again very, very similar. We have this one as x feet, but this one, since they have tick marks there, this implies all these tick marks imply that this is a square. So if this is x feet, then this one is also x feet. Well, now we've got a right triangle. On this one, when I go to use the Pythagorean theorem, a squared plus b squared equals c squared, on this example, I know the hypotenuse already. So on this one, this must be c, because it's directly across from the right angle. This one is the hypotenuse. The hypotenuse. It's always across from the right angle. All right, so I need to plug in 9 for C. So this is going to become, I'm going to use x for A, so x squared. 7 is going to become B, so 7 plus 7 squared. And then C is 9, so 9 squared equals 9 squared. A squared plus B squared equals C squared. X squared plus 7 squared equals 9 squared. So on this example, I'm going to simplify as much as I can. I know that 7 squared is 49. I know that 9 squared is 81. So I'm trying to follow the order of operations. But now I don't have two like terms here. I don't just have two constants that I can combine together. So I need to try to solve for x. I need to get the term with x in it by itself. So a little bit different than the previous examples. This one I need to subtract 49 from both sides. I'll cancel out the 49s on this side. I get x squared by itself. 81 minus 49 is 32. So 81 minus 49 is 32. And then to undo the square, I'm going to square root both sides. So I need to square root 32. And I get about 5. It says round to the nearest tenth, so about 5.7, because this is 5 or more. So I need to round this up to a 7. 5.7. So x is approximately equal to 5.7. And this x length is the same as this length, so that length right there is about 5.7, and we are dealing with feet, so that's approximately 5.7 feet. So you will see some just like that in your assignment as well. All right, here is your assignment, pages 240 to 241, numbers 3 through 8, 11 through 14, and 19 through 22. I'm just going to open up your assignment real quick here. So on 3 through 8, it says find the missing length. On all of these questions, you're using the Pythagorean theorem because you're finding a missing side length of a right triangle. All of them have the little marking there to indicate that they're all 90-degree angles, that they're all right triangles. And just be careful. If you don't know the hypotenuse, then you will have a squared plus b squared equals, and then you just use c squared. If you know the hypotenuse, like in number 3, you'd have a squared, 10 squared, plus b squared equals 26 squared. On that one, you're going to do like we just did on this last problem here, where you know the hypotenuse and you have to solve for one of the other variables. So on number 3, you're going through the same process as this example 4 on the notes. All right, let's see. I know some of you are going to be a little bit frightened by fractions or decimals, but let's go through number 8 together. So number 8, that's the last one of that first little section that you have to do. So on this one, I know the hypotenuse. I don't know one of the two side lengths, and they already called it A for you, so that's kind of nice. They already call them A or B. So I'm going to use A for A. That just makes sense. So A squared plus B squared equals C squared. That's my Pythagorean theorem, used to find the missing side lengths of a right triangle. For A, I'm going to keep it A because I don't know this side length here. B has to then be 4. And C has to be 12 and 1/3. Again, the hypotenuse is C. It's always across from the right angle. So C is 12 and 1/3 yards. So it equals C squared. So the process is still the same, although I know this is not a very nice number, 12 and 1/3. The biggest issue I think a lot of you would have on this problem, and that's the reason I picked this problem, is doing the calculator work. So how do you put 12 and 1/3 in your calculator? Some of you have a fraction button that allows you to input a mixed number, which is great, but a lot of you don't, and I don't on this calculator. So 12 and 1/3 is just 1/3 plus 12. So I'm going to type in 1/3 by doing 1 divided by 3. 1 divided by 3 is 1/3. It equals, that's 1/3 as a fraction, 0.3 repeating, and then add 12. So that's 12 and 1/3. And then I need to square that. So your calculators have a squared button. So typically they use x squared. They might have a different variable, but almost every calculator will use an x and then have a squared. So x raised to the second, x squared. I'm going to square that number, and I get out 152.1 repeating. So now this is a decimal. How do we deal with this? So again, some of your calculators will convert this back into a fraction for you, and some of them won't. But I don't want to write down a rounded answer. You never want to round as you go through a problem and then round again at the end, because the more you have to round in a problem, the more you increase the error. You should only round at the very end. Okay, so 1/9 is actually 0.1 repeating. So this is 152 and 1/9. So a squared plus 4 squared is 16 equals 12 and 1/3 squared, again, is 152 and 1/9. 152 and 1/9. Now, if you left this in decimal form and you just didn't clear your calculator out, that would work as well. You just wouldn't write it down yet, and you'd have to subtract off the 16. So I could subtract 16 at this point and then get this answer. So a squared equals, I know that it's 136 and 1/9, but a lot of you probably do not know that 0.1 repeating is 1/9. All right, so then the last step here is to take the square root of both sides. So if you were just leaving this in decimal form, you just wouldn't write this down yet, and you'd take the square root of it to get your answer. So take the square root, and I get about 11.7 if I wanted to round it. Now the directions on this one just say find the missing length. It does not say round it. I hope that you guys know that 0.6 repeating is actually 2/3. It rounds the last digit up because it runs out of room on the calculator screen, but this is 0.6 repeating, it goes on forever. And if it's 0.6 repeating, that is 2/3. So if you didn't know that, if you put 11.7 on your paper, I would still give it to you, but I hope that you know that 0.6 repeating is 2/3. If not, now you do. All right, so this, I get A equals 11 and 2/3. And on this one, it has the units right here, yards, so I need to use yards. So A is 11 and 2/3 yards, and that's the answer to that one. So that's probably the worst one out of all 6 of those questions. The next section is 11 through 14. The first 3 are very similar to the ones we were just doing. So like if this side's 12, then this side's 12, and you're missing either A or B in your Pythagorean theorem. For number 12, this one's a little bit trickier. On this one, I'm just going to tell you what you have to do, and then I want you to actually try it. So on number 12, you need to find x, but you need the other 2 side lengths to do that. So how do you find this side length? Well, you have to use the Pythagorean theorem with the little triangle first. And then once you solve for that side length of the little triangle, then you'll use that value in the bigger triangle with the Pythagorean theorem. So start with the little triangle using the Pythagorean theorem, call this side like w or some other variable, solve for w, get that number, and then use that number in the larger triangle when you reuse the Pythagorean theorem again. Okay. On number 13, this entire base is 16 feet, and these 2 red tick marks tells us those are the same length, so each of those must be 8 feet. So this is kind of similar to number 12. If each of these are 8, we need to know what this side length is of this small triangle. So this one, we would use the Pythagorean theorem to find this height. So you'd have 8 feet, 10 feet, and we're missing one of the side lengths, and then you use the Pythagorean theorem again. All right, then on number 14, this is a true story for a TV. They're advertised by the lengths of their diagonals. So going straight across here, so if you see a 55-inch TV, it's not that one of the side lengths is 55 inches. They're actually smaller than 55 inches. It's the diagonal that is 55 inches. This one just says a store has a sale on televisions 40 inches or larger. Is the television on sale? So ultimately, you're just trying to see, is this hypotenuse 40 or larger? If it is, then it's on sale. If it's not, then it's not on sale. So you just use Pythagorean theorem. 24 squared plus 32 squared equals d squared, and solve for d. All right, then you have 19 through 22. And those are just review problems, just like I did in the warm-up. So those are going to look pretty familiar. Just remember, if you have a plus or minus symbol to start, you need a plus or minus symbol to end. Okay. If you have a negative symbol to start, you need a negative symbol to end. All right. And that is all I have for you. If you have questions, let me know.